sweet as we can. So today I'll be talking about assessing defocus curve. Maybe some of you have experience with defocus curve. Some maybe just heard of it. But I will just break down and to make it very simple and easy for us to understand. So, in pursuit of visual perfection, post-cataract surgery, everyone now aims for 6/6 without no astigmatism. So, presbyopic correction technique have become a new frontier in cataract surgeries. For example, we have enhanced multifocal IOL, multifocal IOL, and EDOF IOLs. So, like Dato' mentioned just now, there is a need for us to measure the range of clear vision provided by these IOLs. So some manufacturers will provide the defocus curve for the IOLs. So we as an end user, the surgeon, we have to understand the defocus curve very well before we implant the IOL in the patient. So it is not adequate anymore to measure post-operative vision at 6 meters. So we have to know the range of clear vision provided by this lens from near, intermediate, distance until infinity. This is where the focus curve is important. So the focus curve is how we understand the IOL behavior, and also we can compare one IOL to another IOL, one method to different method, how far the depth of focus this IOL provide. And then we can also measure the IOLs through performance, and then by knowing this, we can tailor the IOL based on what the patient needs. Okay. So before we start with the focus curve, if we go to a patient with a crystalline lens, we have to know how to measure the amplitude of accommodation. So amplitude of accommodation. Okay. So by understanding the amplitude of accommodation of a normal crystalline lens, then only we can understand the mechanism of multifocal IOLs that replaces this crystalline lens. Okay, we have to understand these two principles. So now I will start with the focus curve. Before we start with the focus curve, we have to understand the amplitude of accommodation, like I mentioned just now. So amplitude of accommodation is basically a difference in dioptric power between the eye at rest and fully accommodated. That means when the eye is fully at rest, patient is seeing distance at infinity. And then the difference between infinity until the patient can see the nearest that the patient is possible. That is when the lens is at full accommodation. So that range of clear vision provided by your normal crystalline lens, as long as you are still taking. So that's accommodation. Amplitude of accommodation is where the clear vision is provided by the IOL, from infinity until the nearest that you have. So the formula is amplitude of accommodation is equal to punctum proximum, which is the point at near, minus by punctum remotum, which is the point at distance. So from here, once we understand that amplitude of accommodation is difference of power from near until infinity. So near is the closest distance patient is able to read, like I mentioned just now, and the far is at infinity. So as long as the patient is ametrope, and if patient is ametropia, patient has refractive error, we have to correct the refractive error first, so that patient can see infinity at 6 meters. So this is an image that can illustrate my point. So the far point is the furthest point, which image fall on the retina without any accommodation. And we can see here the lens is not accommodating at all. So the image is at far point. So the image falls exactly on the fovea. This is infinity. For our case is 6 meters. The near point is the nearest that object comes to the patient, and then image falls on the fovea as well. This is where the lens is maximum accommodation. Okay, by doing that, we can get the range of good vision from infinity until the nearest point. Okay, this is what we call amplitude of accommodation. Now we have to understand the formula. The dioptric power is equal to 1 over focal distance. So from this formula, we understand the formula dielectric power is equal to 1 over focal distance in meters. We can calculate the amplitude of accommodation. The far point is infinity. So if we divide 1 over infinity equal to 0. So logic, at infinity, no power is required by the lens. So 0 power lah. Okay, as long as the eye is corrected. Okay. And the nearest point is, for example, in this case, patient has a good vision at 10 centimeters. So 1 over 10 centimeter is 1 over 0.1 meter is 10 diopter. This is where the lens is at its maximum power, 10 diopter. This is the range of power that the patient has. Okay, this difference is 10 diopter. So if we use the formula just now, dielectric power is equal to 1 over focus distance. So we know that this patient 1 over 10 is 0.1 cm. So this patient has a good vision from infinity until 0.1 centimeters. That's the amplitude of accommodation. Okay, so far okay? Okay, understood so far? Okay, this is basically what I presented. So how to measure the amplitude of accommodation? First, the traditional one is push-up techniques. This is commonly done by the optometrist. Another one is minus lens technique, which is important in our discussion today. So for push-up technique, this is using RF roller. You can see in the clinic, usually done by the optometrist to measure the dielectric power of the patient, to measure the amplitude of accommodation. Now, the hard part, the minus lens technique. So now we have understood, by understanding the amplitude of accommodation, we know that patient has different power at different distance for the patient to see clearly. Okay, now we use a minus lens. What is minus lens technique? So as we know, in patient with pseudophakia, there is no more crystalline lens to give the accommodative power to the eye. So that is where, in the case of minus lens technique, we have to stimulate. We have to simulate the patient for accommodation. By simulating, by giving a simulating, we know that in the patient, if you give plus power, you are relaxing the accommodation kan? If you sometimes masa buat kat klinik cyclorefract everything kan, you are relaxing by giving a plus power. So conversely, when you give minus power, you are inducing accommodation. You are pushing the eye to accommodate. This is the main principle. So to do that, you have to do a full correction first to the eye. You have to correct the residual refractive power to the eye first. Then only you can test the property of the iota. So minus lens is put on trial film progressively at different power until the last smallest octotype in the Snellen chart can be read. So you are progressively putting a minus lens with different power, so that you are inducing as if you are bringing the image closer to you. Okay. So this is basically a real world test. If sometimes the lab will give you this kind of power, it is tested in lab, but you have to put inside the eye of the patient first, then you can do a defocus curve to test the real world performance. Okay. So to start, you have to understand how do you bring the image closer to you. This is yes.
Just now we put the minus lens, then the patients will view the octotype.
Yeah.
At which distance the octotype.
Okay. Okay, I will explain. Okay, thank you, Dr. So I will start with what is biologic. How do you test the vision at different distance? So first you put the image at infinity, okay? Then you test the vision at that point. Okay, so far okay. This is the normal one that we use. And then if you want to test the vision closer, theoretically you can just bring the image closer to you again. For example, if you bring forward, you test the vision at that point. You bring the image closer until you get the vision drop until the nearest point. Okay, this is by theory lah kan. Why kenapa tak buat je kan? Tapi we have issues by doing that because the closer you bring the Snellen chart to the patient, the image is magnified, so tak tepat lah. So when you bring the Snellen chart closer, the subtended angle of nodal point is changing because by right Snellen chart is always at 6 meters kan, so that you get the constant result. And then it is very cumbersome, very troublesome, especially to the optometrist lah, untuk bring the image closer to you. So this is where the minus lens technique is playing its role. So the minus lens is progressively increasing in its minus power, simulating the image closer to the patient. So let's remind our formula. That 3 power is equal to 1 over F. Okay? So the same principle applies. First, image is at infinity, 6 meters. You correct the eye, no more refractive error. Okay? You want to test the IOL. So no more ocular factor here. This is the IOL factor. So you have corrected the eye. You have removed all the refractive element. And then you put in a minus 0.5 diopter. If you remember just now, 1 over minus 0.5 is 2. So we are bringing as if the image is at 2 meters. But the target is always at 6 meters. Just because you put a minus lens, you are simulating the image at 2 meters. Similarly, you progress with minus 1. You are simulating the image at 1 meter. And then you take the visual acuity. Okay? So progressively, until for this case you put a minus 3 lens, you are simulating an image of 0.33 meters to test the near vision. So this is the basic principle of minus defocus curve. So by doing that, when we plot our graph, we have our defocus lens simulating this range of vision. Okay, this range of distance at different distance. So this is how we understand the property of IOL at distance from infinity to 2 meters, intermediate from 2 meters to 50 centimeters, and at near 50 meters to 33 centimeters, the near vision of the patient, provided by the IOL that we have implanted. Okay, understood so far? Okay, let's move on to how do you interpret the defocus curve. So as we explained just now, it is a plot of visual acuity against successive lens-induced defocus. Okay, just basically the summary of what I talked about just now. So by doing that, we objectively measure the expected vision at different distance by simulating the distance by doing a minus lens test. Okay, this is basically the same as I taught just now. So let's put on the defocus curve. Okay, anyone can interpret this defocus curve now? So it's a bit daunting, right? If you see straight away what defocus curve, where do you start? So we understood just now.
0.5.
This minus lens is simulating a different distance. So at 0 it is at infinity, minus 5 is at 2 meters, and so on and so forth. So from here, you can see with this minus power, we can interpret the vision at distance, intermediate, and at near. Okay, so for example, this is a presbyopic patient with different age group. Okay, so if we decide the good vision is at 0 log mark, which is 6.6, okay, this is the line of good vision. If we take the age of 37 to 39, where the good vision is, the range of good vision. See, patient has very good range of vision from infinity until near. The vision is good all the way across, from the far until near distance, including intermediate. Progressively with age, patient has worsening vision at distance, at near. So now patient can only see until intermediate. And then at the 43 and 45 age, patient can see only at around 50 centimeters. And lastly, at the age of 48, patient can only see until 1 meter. So we understand now, with the focus curve, we can see the worsening progression of vision, especially in the near and intermediate in this age group. Okay? So far, no, any questions? Okay, now we move on to different defocus curve, presbyopic IOL correction. So anyone want to try? Ikmal?
Okay.
So what about the first graph?
Scrum.
What's the
So
focus curve?
there is no minus
Basically the lower part is minus, minus.
minus.
It's not
Alright,
minus.
alright. Okay.
This is minus the focus curve.
Okay. So dogma 0 equivalent to 6.
Okay, first we start with near, intermediate and distance, kan?
Okay, alright.
So 0 is at infinity.
0 is infinity, 0.5. Apa tadi? Ada.
Tidak. 0.5 is distance. 0.5 to 2 is intermediate. And from 2 until -4, -4.5 is near. So we know that this is the range of vision. And for this chart, the good vision is the clear vision at 0.2. This is depends on the manufacturer. Sometimes manufacturer decide clear vision is at 6.9, for example, kan. And different manufacturer or different researcher will give a different criteria for clear vision. So just now I mentioned clear vision is at 6.
0.
Tapi this paper describe at 0.2, so around 6.9 will be a clear vision there. So now we can understand the monofocal IOL can only provide from infinity until 1 meter with a vision of logma 0.2. So this is monofocal. Okay? So for EDOF, the lens can provide until until 50 cm, until intermediate vision. Okay. So similar here, EDOF can provide until 50 centimeters of vision for logma 0.2. Trifocal can provide a better range from infinity until 3 centimeters. Okay. So we can see different IOL types provide with different range of clear vision. So we can compare with different IOL. Just now we compare with age, kan? So now we can compare with similar defocus curve. We compare with different type of IOL. So this is now I will talk about clear vision criteria. Okay, some paper or some researcher or some manufacturer will decide what are the clear visions. Sometimes some paper describe as 6.6. Sometimes the researcher will describe at 6.9. It depends on the researcher. So that's why there is a inconsistencies among studies or among the focus curve. So for example, if we take this chart, this paper takes the clear vision is at logma 0.3. So if they compare the monofocal with multifocal IOL, the monofocal can provide at vision of 0.3 logma from infinity until 67 centimeters around intermediate vision. And multifocal can provide from infinity until near vision, which is very good. Can the whole range, but it is only at logma 0.3. If the clear vision is set at 6.6, okay, this is the monofocal vision. This is multifocal vision. So if we take 6.6, the multifocal can only provide 6.6 vision from infinity until 1 meter only. So the clear vision will determine the range of clear vision by the IOL provider. Okay, understood so far? That's why if we understand the clear vision criteria, we can interpret the graph. Okay. Now there are some issues with the focus curve. This is study by Navdeep Gupta from JCRS Journal. Every defocus curve are not standardized. Some use a different criteria of clear vision, like I mentioned just now. Some use 6.6, some use logma 0, some use logma 0.2, some 0.3, some 0.4, depends on the researcher or manufacturer. So they are also worried about memory effect because you are putting the same lens. You are putting the lens, but the target is always the same. So patient sometimes letak 23 IOL, letak 23 minus lens. Patient already remembered all the autotypes. So your defocus is not that accurate. That's the concern. And then is also worried about miosis-induced near triad. So you are simulating a near vision by putting a minus lens. So sometimes when you put a near vision, the pupil is getting smaller. When the pupil is smaller, the range of clear vision is increased. So you normal pupil, when you have a small pupil, your vision is your range of clear vision is better than when you have a dilated pupil. So that's some of the worries related to the defocus curve. And then there are some defocus curve putting a minus lens only. Some put positive lens also, because we understood patient has no crystalline lens again. So why do you have to put positive lens to the patient? You don't want to relax any more accommodation kan, by logic lah, because patient does not have any lens anymore. But after they are doing the study, you still have to put a positive lens because the study says that it is to confirm the correct point of clear vision. So you have to put to complete the graph lah basically. That's because it is statistically and mathematically representative of a normal lens. So after they compare with the normal lens, you should put also the plus, because that's the statistical and mathematically correct technique, which is curve fitting lah. They are also worried about magnification effect of the minus lens, because we know when you put a positive lens, everything becomes bigger kan? So when we put a minus lens, we are worried that the image will become smaller, so the vision is not accurate. But they suggest using the formula to correct the magnification effect. This is for the research lah. Okay. So to conclude, this is the defocus curve. The IOL is put at sequence. So they suggest to randomize the IOL. The minus lens. Randomize the sequence, so that patient will have no memory effect. And then you also have to put a positive lens to complete the curve. And then the best criteria is for clear vision is best BA plus minus 0.04 logma. This is a variable lah you have to put to decide for clear vision. This is the suggestion of the study lah. Okay, that's all. Thank you.
So you understand why that is important. Why we give time for Dr. Huzaifah to actually explain this, because you cannot rush this. You have to go to the very basic, then you understand. So later on, if somebody give you a defocus curve, you actually be able to see, because everybody give you defocus curve, saying that okay, this IOL is better than the other. Now a lot of monofocus saying that they're intermediate as well. Then they have come term with mini monovision, you know, and we have a lot of EDOF actually targeting that as well, mini monovision. So it becomes very confusing to the surgeon looking at this, and that's why we actually have to address that, and we thank Dr. Huzaifah for the excellent presentation. So we have another one presentation before I conclude it later on. That will be Dr. Shafi. Dr. Shafi was given a task on the post LASIK, because that's another thing that people keep saying it.